Jaden Cobb, and I'll be speaking today about making predictions regarding the outcome of UFC events. The data that I'm using for this comes from Kaggle. It consists of two different CSV files. One of them is the Master UFC datasheet, which is basically just all the recorded data from every UFC event up until the previous Saturday. The other CSV file contains data for upcoming events, for instance, the event that will be taking place this Saturday. The data is pretty massive. There's about 411 different columns available to use here. Here's some examples of them just to give you a general idea. You can see things you would expect like significant strikes thrown, takedowns landed, betting odds. Those are going to be really important. The machine learning algorithm I decided to use is called XGBoost. XGBoost is a decision tree-based ensemble algorithm, and it incorporates a gradient boosting framework. It's often referred to as the all-in-one algorithm and can be seen used in many of the different Kaggle competition winning submissions. One of the main reasons I chose to use this algorithm is because in general it is seen as just a massive workhorse. I also wanted to use something that is seen frequently in the real world when it comes to data science. XGBoost also comes with a built-in cross-validation method called Grid Search CV, and it also does a fantastic job of feature selection and visualization of feature importance. The data processing segment was fairly straightforward. Typical things like replacing null values, standardizing them, and defaulting everything to the same type case. One thing I did need to do was to create a target variable to signify the winner of each bout. And you can see that here, that I did that via a simple getter function. To differentiate between the two fighters, I decided to just go with the corner color and basically just set it up as a Boolean outcome value. Here is the meat and potatoes of my model, where you can see the XGBoost actually being fit. The trickiest thing about XGBoost is actually finding the right parameters. One thing that helps is that it has its own form of hypertuning built in, and you can see that here with the optimal parameters output. I basically started with the default recommended parameters and played around with them until I found an accuracy score that seemed to be on par with what I was expecting. As I said before, XGBoost does a great job of helping with feature selection and showing the importance of different features. You can see here the model will output a score of importance that indicates how useful or valuable each feature was in the construction of the boosted decision trees. The more an attribute or feature is used to make key decisions with decision trees, the higher its relative importance. Using my model, I made predictions on November 7th for the Thiago Santos vs. Glover Teixeira card. Here you can see the main card and the prelims, as well as the betting odds for each bout. And here you can see what the predictions actually look like. The model provides a float value for each fighter based on their respective corner color, where R is red and B is blue. So the highest accuracy score my model ended up achieving was actually 66%, and I wasn't sure how well my predictions would do in a real-life application, but of 9 fights predicted, the model actually got 6 of them right, which I've denoted here by placing a gray triangle next to. The interesting thing here is that the accuracy score of 66% ended up being almost identical to the 67% success rate. I was pretty pleased by this outcome. This has a huge financial implication when it comes to sports betting. I have never personally done any sports betting, but in the event that I did, 3 out of 6 of the currently predicted fights would have doubled the bet of 100, and obviously that scales with higher amount bets. Overall, I was really surprised and pleased with the outcome of this work. I don't think I'm really done with it, and I plan to keep working on it and possibly predicting upcoming events to see how consistent I can make the model. I also think that it would be interesting and entirely possible to use this model to predict outcomes of other sports. I assume the people that do place money on the line and engage in sports betting are looking for any sort of upper hand and would be very interested in a web application. And I'm hoping that is something I can potentially make happen in the next upcoming months.